Hey friends, we have a new sponsor today, and I want to make sure that you support them because they make Hansel Minutes possible. RavenDB. It's a document database that's non-relational and fully transactional. It's available for Windows and Linux with official client APIs for .NET, the JVM, Go, Ruby, Node.js, and Python. RavenDB is designed for high performance, handling tens of thousands of requests even on a single node. Now, RavenDB is capable of on-the-fly optimization, dynamic indexes, and much more. It has a fully loaded GUI, which means it's simpler to operate, and you don't need, arcane incantations on the command line. It just works. It's fast and it's right. Download your free community edition at ravendb.net. That's RAVEN db.net. I hope you check it out. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I am talking with Caitie McCaffrey. She is the engineering lead on Azure Sphere. That's a cool code name. Is that like a code name or a thing?
No, this is our official real name now.
Awesome. I like cool names. I would hate us to call it something boring.
Yeah, I'm pretty happy with the name we got. It's exciting to have it be public and out there.
That's awesome. So I can go up and just, search for Azure Sphere or Microsoft.com/Azure-Sphere. And it says a solution for creating highly secured connected MCU devices. MCU, I had to go and search for what that is.
Yeah, so an MCU is a microcontroller unit. So you can think of these as really tiny chips about the size of like your thumbnail or a fingernail. And we like to differentiate this. This is basically smaller than if you think about an Arduino or a Raspberry Pi. Usually an MCU, you can think about it if it's something in your house that has a button or a light or maybe a really low powered display, like a monochromatics display, that's probably running an MCU.
Okay. So I've got lots of Raspberry Pis, but I can boot those up into a desktop and they run like I don't know if the right word is a proper OS or a desktop OS. Like they have a lot of weight to them.
Yeah. So those are bigger than microcontrollers because they're doing more things. They have, you can think about it, a high level operating system that has a user space in it as well.
The user space. Okay. But I'm looking, for example, at an Xbox controller that happens to be on my desk here. That probably doesn't have an operating system.
It has an operating system of sorts, but it's not as fully featured as you would think of as like your traditional Windows or Linux or Arduino operating system.
So then all these things that I'm looking at, they're scattered on my desk here. I've got, USB to SD card adapter, and I've got a tiny Linksys USB Wi-Fi thing. How can I tell what's an MCU? Does it have to be connected, or does it have to have Bluetooth or Wi-Fi to be an MCU?
So MCUs traditionally don't have to be connected, and most of them are not. For instance, there's 9 billion MCUs created every single year. So that's like a lot of them. They're kind of in everything. Like most appliances in your house have an MCU. You can think of MCUs are usually in anything that has like a switch or a pump that's controlled with some code, right? It's just a very lightweight computer chip that you can run sort of simple logic on to control things. But now the interesting thing is many of these are becoming, only like 1% of them now are connected to the internet. But that's sort of all changing, right? Everyone wants to do IoT and have smart devices and extend the cloud to the intelligent edge and bring that into your home or your workplace or factories and make that a richer experience where you can gather more data.
Yeah. And as a user, not as a developer, but thinking in terms of a user, I can say that I've got all these devices I'm kind of an early adopter. I've got light bulbs and switches and they're voice controlled and stuff. The thing is though, it all feels very tense. Like I feel the psychic weight of these devices pressing on me because like I bought this cool light bulb on Kickstarter and now that company's gone out of business, which means that I now have this device that has a little operating system that has no firmware updates, ever. And like that light bulb it's silly to say this, but it's stressing me out.
Yeah, because it's talking to the internet, right? And so internet
Yeah.
connectivity is sort of this two-way street where it provides a lot of really useful functionality, right? Like you can do a lot of cool things with this light bulb or with, a connected thermostat or even your refrigerator, for instance, right? But then we've also now invited attackers or hackers into our homes by providing internet-connected devices. And so they love when things aren't updated because they can find an exploit and then use it forever. Just think of this scenario where you like come home and you have an email in your inbox that says, give me 5 Bitcoin or I'm going to melt all the ice cream in your freezer. Like, right? Like that's sort of, the world we're in. And that's a funny example, but I think there are realer ones around, like, if you think about, like a stove, for instance, like a gas powered stove that you could remotely turn on and off, like that could be weaponized because it's connected to the internet, where you could turn the gas on and then later a hacker could remotely light the ignition.
Yeah, well, I mean, keep in mind who you're talking to. I've got an insulin pump that is ultimately cloud connected, although there's a couple of bounces between that pump and the net. And there's been lots of examples of, episodes of Law and Order where some poor schmuck gets killed by a hacker because they deliver too much insulin. So I think your point about, the need for security is intense.
Yeah, and we really looked into what we designed Azure Sphere to be is from the ground up. Let's think about security and how we secure these internet connected devices that are going to be prevalent and everywhere.
That's interesting because I feel like the last, 5 or 10 years and watching this as a hobbyist and getting involved in IoT, I'm just buying all sorts of chips that I see from various vendors from overseas, and they're all very hobbyist and fun. But I feel like if we were going to go and secure them, we'd be playing kind of whack-a-mole.
Exactly.
And so you're saying that Azure Sphere is not just the cloud, it's not just the OS, it's the chip, the OS, and the cloud all as one platform.
Yes. So this is sort of like the first end-to-end holistic solution for all of this. And one of the things that I think is super cool about this project, when I joined it about a year ago, is this started in Microsoft research. And Galen Hunt and crew basically spent some time looking at what does it even mean to have secure connected devices? Like what properties would we have to have? Let's take a step back and look at it from first principles and take learnings from, all of the learnings from securing Windows and updating Windows over, however many years. And like, let's look at Xbox, right? And what learnings can we get from, 15 years of securing the Xbox? And so they published a paper called The 7 Properties of Highly Secured Devices that lists these 7 properties that you have to have that we believe are fundamental to providing a secure connected device. And then from that, Azure Sphere was created to everything's rebuilt from the ground up to fulfill those 7 properties.
Wow. And that PDF, of course, is still available online. You can go and search for it. It hangs off of Microsoft.com/research. And it talks about the hardware, kind of the root of trust. Like nothing is secure unless the hardware and has crypto at the root level.
Yes. So, and what's cool about the 7 properties is if you go and look at them is, some of them we can do just in silicon, like the root of trust, like you mentioned, but some of them we actually need all 3 components, which is silicon, operating system, and cloud. So one, that is called renewable security is like actually providing updates, which you touched on earlier. And so we need silicon and an operating system that knows how to provide updates, and then a cloud service to actually push those updates out, which is something that Azure Sphere provides.
It's actually a very, like, you think about reading a paper by a bunch of PhDs might be really dull. It's actually quite a good paper, and it's quite easy to read. And it says a lot of things that make you go, like common sense type stuff. But I like the way that it phrases. It says single purpose hardware should be immune to reuse for unintended actions. Like, this is a light switch. It should only switch on my light. It should not, kill my family.
Right. Yes, that would be an ideal goal for a light switch.
So the idea being that we want it to do its job and do its job as intended and kind of melt into the fabric of our lives as users, without all the psychic weight of my light bulb stressing me out. That's one light bulb that I bought on Kickstarter. Imagine if you're a big car developer and you've got now, multiple millions of cars out there, or multiple million refrigerators. That would be very stressful. And they're refrigerator makers. Like we've seen on Silicon Valley, people hacking into appliances. Like, that's not their job to be worrying about that stuff.
Right. And so Azure Sphere is basically sort of this turnkey solution where we say, like, here's a tool, here's a productivity tool and a solution basically where if you use an Azure Sphere certified silicon chip, and then you get, once you buy the chip, you get licensed to use the operating system for 10 years. And then you also get 10 years of the security services guarding that device. And then, so you just don't have to worry about it, right? You could build the application for your refrigerator or, whatever you are building and just think about that. And then we take care of the security for you.
So you say that it has three components, chip OS and cloud connectivity. When you say chip, like I know that we're in the Surface business. We make computers now, although I'm sure that we outsource a lot of the parts and stuff. Are we suddenly making chips, or where do these chips come from?
Right. So the piece of Azure Sphere, you may have heard me say certified Azure Sphere chips. So we work with silicon partners who actually produce Azure Sphere chips. And what makes it an Azure Sphere chip is that it has the Pluton security system is silicon that was developed by Microsoft and that we license royalty free to these silicon partners so that they can then make these chips. So MediaTek is our first partner that is producing the first chip. And so you can go look and see the specs on their website. But device manufacturers and whoever wants to buy these chips would actually be buying them from the silicon manufacturers. And there therefore could be many, many different SKUs in the future. I think there are 12 silicon partners announced on the website right now.
I see. So I'm going to ask a very ignorant question because the most I ever did in the hardware space was I made a clock with a bunch of NAND gates. So we've designed, or Microsoft has designed the silicon in the sense that they would give or license the plans and say, here's the layout, here's the silicon and how you lay it down. Like just as I give you source code, but you compile it.
Yeah. And we actually give them like a block. And so there will be that Pluton runtime subsystem on the chip, but there could also be additional things like, for instance, different cores. And some of it we do have specs around, like we have an application core and a real-time core on these chips, and we call that a crossover chip. So that's a requirement, but there's other things that go in. So it might be like you can think of it as like an interface and some code that I give you.
I gotcha. And then the one from MediaTek, and you can go up and search for this if you like. It's got an ARM processor. It's got two general purpose ones. It also has a dedicated Wi-Fi subsystem. So it is connected by default.
Yes, and all the Azure Sphere certified chips will be connected by default. Mm-hmm.
That's cool. Now, I'm making a refrigerator. Do I build a bunch of stuff that I know how to build as a refrigerator manufacturer, and then there's a thumbnail-sized hole in my board, and that's where I pop the Azure Sphere in?
Yeah, and so that's up to obviously the device manufacturer about how they want to lay out their boards. But wherever you would put your chip on your board, that's where you would place it. And then you might. This is a whole very complex beast, right? So yes, you take our chip, you put it on the board, and then you could design your own board from there.
So the whole point is, though, to be secure. Are we going to offer? Is Azure going to offer like? This part's secure because it's Azure Sphere, but this other stuff around it that I made when I did my refrigerator is not secure because I did it wrong or I didn't know what I was doing.
Yeah, so that's a great question. So we part of the operating system that's super cool, I think, about we call it a high-level operating system that we built from the ground up to be secure, has basically an application sandbox. And so as a device manufacturer, you would write your refrigerator app, and then you would put it in our application sandbox. And so it's actually a multi-layered operating system, whereas if you think of an RTOS that usually runs on these devices, it's all like one big component. And so it's once you compromise any of it, whether it be the application or the kernel, the whole thing is compromised. We actually have different layers, like you could think of in your traditional kernel, like user space and like more like the kernel space and things like that. So device manufacturers can run in their application sandbox. And even if, for instance, there was a vulnerability that was discovered in their application, they could then push an update over there to fix that. And the rest of our operating system would ensure that application got updated.
Now, you said RTOS, real-time operating system?
Yes, so that's traditionally what runs on microcontroller devices. This is actually a super old operating system. It was built originally before devices were even connected to the internet, right? And so internet connectivity and security has sort of been added on and sort of like taped, sort of duct taped on, and these features have been added. But there's still vulnerabilities that keep popping up in that and things like that. And so we actually built one from scratch to go and say, would it look like to design an operating system for these small devices from the ground up so that it's purpose built for security.
Mm-hmm. You've seen probably online everyone lose their minds when the Sphere OS announcement came out, and there's a whole bunch of stuff to read about. I've got dozens and dozens of pages open. I've read the original PDF about the characteristics one needs, but the title, the headline is Microsoft makes its own Linux. And I'm like, this seems a lot different than what I thought people think is being made. So why did everyone focus on that?
I think so. Yeah. So I'll address the question is our high level operating system does run a custom Linux kernel. It has sort of 4 layers, which is our security monitor, our custom Linux kernel, applications that run as part of the operating system, and then there's your app that runs. And so the custom Linux kernel, I think, it's funny. I feel like every time I see this, everyone forgets that Microsoft has a long storied history with supporting Linux, right? 40% of the VMs that run in Azure are Linux based, but I think it's just maybe some sticker shock over the history of Microsoft's careers. Mm-hmm. And having Windows versus Linux and this sort of dichotomy folks have in their heads, but it's really nothing new.
Mm-hmm. Well, and it seems like a reasonable thing to choose, given the size of the operating system and the modularity of it, as well as the ubiquity of Linux. I expect people would have code that would be more compatible because you're using Linux as the operating system.
Yeah, and I think I don't even know that it's necessarily a size issue. We've cut down the Linux kernel. We have a custom Linux kernel, partly for security, because mm-hmm. You don't want to ship a shell on these devices because you don't need it, and so that's just mm-hmm. a different attack vector that we're not exposing, for instance.
I see. So this is not really an operating system as it is a pared down modified kernel.
The Linux bit is a custom pared down kernel, and then we have built an entire operating system around it.
I see. And then as open source, is this a thing that I'm going to go and learn about and poke about, or does it have to be open source?
So we will basically follow the license, the GPL2 v2 licenses, and so there will be more information on what as we publish that and adhere to that license in the future.
That's cool. Hey folks, I want to take a moment to thank our sponsors and remind you that when you support them, you're supporting Hansel Minutes because they make this show possible. Innovative developers help improve the lives of millions of small businesses and accountants that use QuickBooks worldwide. Your app could make the difference that helps them work smarter and put more money in their pocket. Enter Intuit Developer. From tech tools to growing your customer base to helping you get funding, Intuit Developer helps your app go from concept to company. Find out more at intuit.me/code. That's intuit.me/code. So is this something that is going to show up in my light bulb, or are we thinking that this is not light bulb appropriate?
So it depends. Some of this is, if you think about light bulbs themselves, usually they run very, very small chips. Sometimes you might think, if you're familiar with the ARM ecosystem, it's called an M0. So that's a really, really small chip. What is on the first Azure Sphere certified chip is an M4, which is a slightly bigger real-time processing core, and then an A7, which is an application level processor, which is actually more powerful. And so that's sort of new to the ecosystem. But usually what's determined there is based on the cost of how much do you want your light bulb to cost, right? Is how beefy of a chip we could put in it.
I see. And if you look at this, at the diagrams online, there's this whole family tree of these ARM processors, from the tiniest to the ones that run on watches that go all the way up and can run a whole computer almost.
Mm-hmm, mm-hmm.
So this is the ultra low power M0 is maybe sometime in the future, but you're starting at the M4.
Well, I mean, our chip does MTK's chip does have 2 M4s on it and an A7 processor, so it actually has multiple cores. So while we realize that we're sort of not targeting the super, super low end MCUs in the current SKUs that are being built by our silicon manufacturers right now.
Mm-hmm. Where do you see the cloud side then? What is the thing in the cloud that supports these tiny devices? Because on the tiny devices, they've got, of course, limited everything. They are limited by the design, but the cloud is the exact opposite. By design, it is unlimited, infinite.
Yeah. So what's super cool, maybe I'm biased because I run the cloud security services, but what I think is super cool is it provides a couple key features. One of them is certificate-based authentication via remote device authentication and attestation. And I'll get into more of what those mean. There's renewable security, which I briefly mentioned earlier. So you can think of like providing operating system updates and a secure pipeline for device manufacturers to provide their own updates for their applications to the devices. And then the third one is failure reporting. So these actually align with our 7 properties. So we proactively get information about the device about when it's crashing and when like things are failing so that we can detect potential attacks that are brewing as people probe to see. Usually an attack will be predicated by, you'll see a bunch of crashes as people are trying to probe a system to try and do a buffer overflow or whatever their attack vector is. So the cloud does sort of all of this for you. I think one of the cooler ones that was like, it took a while for it to sink in, and then I didn't even realize this when I first started, but basically, if you think about default passwords, right? Like we've sort of realized as a security industry, passwords are not great. They're easily stealable or hackable or whatever.
Sure.
And a lot of these IoT devices come with a default password. And if you remember the Mirai botnet attack that happened a little over a year ago, I believe, or 2 years ago now, that was hackers exploiting the fact that these devices have default passwords. Users often don't change them because like you might not even think about this thing being in your house. And it's just a pain to go and change the default password. And so they were able to then gain control of these devices using just a default password. So Azure Sphere doesn't even have this attack vector because we don't use passwords anywhere on the device. We issue certificates.
I see. Which is interesting because it gets to that point you made at the beginning, which is let's just start from first principles.
Right. And so the cloud security services will basically issue certificates to every Azure Sphere connected device to say that, yes, this is its own device. Like every device gets its own certificate that uniquely identifies that device and that it is running what we consider to be valid, secure software. So it's actually doing not only, identity authentication, but attestation of the fact that it's running valid software.
I see. So the ISO, kind of that built-in isolation means that if a bad person gets a hold of something, whether it be remotely or physically, you really are compartmentalized.
Yeah, I mean, so for whatever reason, if you could get a certificate and run bad software on one device, you're only getting a certificate for that single device. There's no like broad attack vector here, right?
I see. There's no skeleton key certificate for all the system.
Right. And what's actually super cool about these certificates is that you use it to authenticate to the cloud security services, obviously. And then you can also then take this certificate as a device manufacturer and use it to authenticate to your device applications. And that could be in Azure, which there's like a great story and path there. But if for whatever reason you want to go and use a different cloud because maybe you already have that set up, like AWS or Google, or you have your own custom servers, like you can take that certificate and use that with any service.
When I heard, we've hung out before, and I've met you, and you're always doing amazing stuff. You worked at Microsoft, you worked on Halo, you worked at Twitter, and then I heard that you were coming back to work on this, and I at first I was like, what? Like that doesn't sound like I think of you as like the giant cloud scale person. Like when you went to Twitter, I was like, oh, she's going to go and do stuff of even larger scale. Like that's always been your thing. And now I'm thinking about these tiny little devices. And I was like, why are you doing this?
Yeah. So, so the devices themselves are small and the code that runs on the devices is small. But when you think about them in aggregate, right, like 9 billion MCUs, the market is 9 billion MCUs are being produced every single year. Even if we only have a fraction of them hitting our services, that'll actually be bigger than anything I've ever built in the past. So this is actually an even bigger large scale challenge for the services I've built prior to this.
I see. So this is well in your the stuff that you work on. It's giant scale.
Yes, it's a giant scale. I still find that incredibly interesting. And then, I was also very enticed by the security aspect of it. This is personally, like I've been watching the IoT space for a long time, and I think it's super cool, but also realizing that like there isn't a great security story around a lot of the devices out there currently, right? And so I think in order to enable like, more device manufacturers and people to be more productive and do this safely, there needs to be a great security story out there. And so this sort of aligned with that interest. So I think the impact is huge because we could build things that we can now trust and put in our homes.
Can you, maybe this is appropriate, maybe it's not. Have you talked about this thing that you worked on before, distributed sagas, and does that relate to the stuff that you're doing now?
So we're not using distributed sagas at currently right now. That doesn't outline it. So for those listening who might not know, distributed sagas are a pattern for doing sort of long-lived transactions in distributed systems, except for we don't provide, it's not a full-blown distributed transaction, but it is a pattern for ensuring something either all happens or doesn't happen in a rollback strategy. So I've used distributed sagas in Halo. I've used them at Twitter. Right now, we don't currently have an implementation in this stack. That doesn't mean we wouldn't use it in the future.
I see. Okay. So sagas would be for like big, giant, two-phase commit, huge cloud scale transactions.
Yeah. So the example I use a lot is if you're like booking on a travel site, for instance, you might want to book a car, a rental car, a hotel, and a plane. And those are all talking to 3 different microservices, right? That don't even have the same storage behind them probably. And so how do you ensure that either you get all 3, or if you can't get all 3, you have to like roll back the operation that you ensure that the rollback completes successfully so that you end up eventually in the state of you either hold all the reservations or hold none of them.
I see. So part of the big scale stuff that you worked on, but not currently specific to anything around Sphere, maybe someone who was doing business stuff on top of all of this would implement something like that, but not related.
Yeah, and I think as the Sphere security services grow, we might find a great use case where bringing this in makes a lot of sense.
When I'm digging into the 7 properties of highly secure devices paper, it's always talking about defense in depth and compartmentalization and certificates. I always brings me back to that joke that the most secure device is one that is not connected to the internet. Yeah. I'm curious, is it just a constant series of trade-offs? It's like, well, we really just should not be connected at all at this point. I mean, you're asking for it when you put anything on the internet these days.
So I think, it's definitely anytime you put something on the internet, you have now opened it up to being attacked, right? It's a two-way street. I believe, and we believe with the 7 properties that we can secure these devices and respond to any potential attacks as well. It gives us the idea to say, like, right, we're not naive. We don't think this will prevent every single problem in the future because it's a cat and mouse game with security, right? But it does give us defense in depth and compartmentalization and certificate-based authentication. And all of these properties give us the ability to go in and fix or update these systems. Yeah.
And it also, one of the things that was interesting was the idea of failure reporting, that in order to be secure, a device needs to be able to talk to a failure analysis system, in a timely manner.
Yeah, and so I think failure reporting is really interesting from this perspective of us trying to prevent things in the future and detect potential attacks, I guess, before they happen. It's a little Minority Report-ish if you think about it, but it's a cool idea.
That's an interesting point. You can say, this looks suspicious, right? It's just like when I was working on banking, we would have varying levels of suspicion around something like, oh, you logged in. Okay, well, it's you, same IP, same browser. It's probably fine. We'll just ask for your password. Hey, look, now you're in Russia on a Wi-Fi in a strange hotel with a new browser.
Right.
This all added up to varying levels. And then we're going to double challenge you or triple challenge. Now you're moving money.
Exactly.
Varying levels of trust.
And you can think about this for developers who run services. This is sort of like observability and metrics of what these devices are doing, right? Like, just like you would look at a server and see, like, are you seeing a bunch of crashes? Something's probably wrong with the software or about to go wrong, right? Or like the calls are becoming more latent. Like, this just gives us visibility into what's actually happening in these devices in the world, where a system that didn't have failure reporting would have no visibility into what's going on.
Is updatability one of the things that's part of this? Because I don't want to, have my non-technical spouse flash the firmware on the fridge. It's not really her job.
Yes. So one of the properties that the cloud services provides, renewable security, is for 10 years of these devices, we'll commit to updating the operating system and shipping regular updates. So, and you don't have to think about it. It just, our operating system does this for you. And then the device manufacturers can also ship their own updates, whether those be security patches or, for instance, lighting up a new feature that they want to give you access to.
I see. And then does this all plug into the Azure IoT stuff that I already know how to do?
Mm-hmm. Yeah, so you can use this easily with Azure IoT. You would take that certificate that the security service has issued you and use that to authenticate to your Azure IoT hub so that you could process the telemetry you already use. And there's a whole connected devices setup that's very, very easy, sort of like 1-2 button clicks that's a great experience.
Mm-hmm. So last question I want to ask you, because I've always wondered, is everyone's talking about IoT edge, like the edge, the intelligent edge, the edge. I have no idea what any of that means. Why is it on the edge? What edge are we on?
So Azure IoT Edge is a super cool product. I think this edge that we're talking about, and it was funny at RSA, like a lot of folks were confused about the Azure branding name, because really if you can think about it, the cloud edge is expanding, and maybe that gets a little philosophical, right? But if you think about it, we're putting all the data processing and all the information and knowledge used to be in single data centers in the cloud, right? And now we're reaching out to the edge and saying, there's compute running at the edge, and there are these devices that are collecting and reporting data at the edge, and those are really part of the whole cloud ecosystem.
I see. So if I've got a thermostat, I can centralize all of the information, or I can think, well, this is a much more powerful device than it used to be. It's a little database of its own. It can hang on to the data, and I'll go and get it from the edge. Mm-hmm. Mm-hmm. Okay. I was just trying to figure out, I've seen Ready Player One, and I just want to understand where the edge is and how far we're going to push it.
I think it's an always moving boundary. Yeah. It's do you want me to draw a line on your house where the edge is?
That would be great, yeah.
Do a little purple pen marker of here's the edge and here's the cloud.
So if people are listening, if listeners for the podcast are into this, what do they do? I'm looking here, where's the sign up now? Or do they have to call someone to learn about this if it's perfect for what they're working on?
Yeah, so we basically announced at RSA that we are in private preview. And so I believe if you go to the websites, there's a way to contact us, or you can always email azuresphere@microsoft.com if you're interested. And then we've talked about being in a public preview sometime later this year. And then the first devices that a device manufacturer will produce containing an Azure Sphere certified chip is targeted to be on shelves by the end of the year.
Very cool. This is great. Thanks so much for explaining this to me.
Awesome. Thanks for having me, Scott.
All right. This has been another episode of Hansel Minutes, and we'll see you again next week.